Let's look at an example of how to find the area bounded between two curves. Specifically, we're going to look at how we can use the graphing calculator to help us solve such a problem. Here's an example. It says find the area of the region bounded by the graphs of the given functions. And we're given two functions. In general, to solve this type of question, you use this formula. The top function minus the bottom function over the region. To do this, though, you have to know what the top function is and what the bottom function is, and you have to know what the start point and the end point are. The start point and end point are the intersection points of these two functions, where these two functions are equal to each other. The only way to know what the top function is and the bottom function is to look at the graph of these two functions. So the only way you can solve one of these problems is by looking at the graph. Don't attempt the problem without first graphing it. We can use the graphing calculator to help us graph it. The first step is to enter the functions into y1 and y2. So y1 is my f of x, y2 is g of x. Make sure you keep in mind which one's which. Remember, when you go to graph, you might have to play around with the window settings to get a good view. With this window, I'm able to see the graph nicely. Now be aware of what your scale is for the y-axis and the x-axis. My scale was 1 for the x-axis and 5 for the y-axis. This is the area we're trying to find because this is the region bounded by the two graphs. To find that area, we use this formula. But there's two questions we need to answer in order to use that formula. We need to know what's the endpoints, that's the a and the b value, and we need to know which function's on top. Since the order matters here, the top function minus the bottom. You can't do it the other way around. To find the endpoints, that's the a value and the b value. A is this x value, whatever this point is, the x value there, and b is the x value of this point. Those points are the intersection points of the two functions. You can find those points algebraically by setting the two functions equal to each other and solving for x, but you also can find them using the graphing calculator. We'll look at that in just a second. Then also, we need to figure out which function's on top. We have this red function and this blue one. Looking at the graphing calculator, we see that the blue is f of x, that's what I labeled y1 as, and y2, g of x, is the red one. So we can see that g is on top and f is on bottom. So applying this formula, we must do the integration of g of x minus f of x. Now we just need to figure out what a and b need to equal. We need to find the endpoints. We can do that using the graphing calculator. We want to find the intersection points of these two curves. To do that, go to the Calc menu on the graphing calculator, second trace, and go down to the intersect option, option 5. You'll be asked three questions: first curve, second curve, and guess. First curve means what curve do you want to find the intersection between. So we want y1, so we click enter, and y2, so we click enter. Then it says guess. It means move the cursor to where you think the intersection point is. Now we have two intersection points, this one and this one. We have to find them one at a time. Let's find this one first. So we can move the cursor close to that intersection point. It doesn't have to be perfect. There's fine. Click enter. And it tells you the intersection point. X equals 2, y equals 10. So we know this point is 2, 10. A is the x value of that point. So a equals 2. So now let's repeat these steps to find the second intersection point. First curve, y1, second curve, y2. Now it says guess. So you can move the cursor by hand, but sometimes it might take a while, so you also can just type in the x value. This is x equals 7, so we can type in x equals 7, and it will take us over close enough to this point here. Type that in, and it tells us the intersection point is at x equals 7, exactly. So now we know this point is the point 7, 20, and b is the x value of that point, which is 7. So now, going back to our formula, we found the value of a and b. So we've completed everything. Now we just have to evaluate this definite integral. We can really easily do that using the graphing calculator. Remember, in the graphing calculator, y2 is g of x and y1 is f of x. So we need to do the definite integral from 2 to 7 of y2 minus y1. The definite integral is underneath the math menu. Option 9, a equals 2, b equals 7. Then we need to do y2 minus y1. dx. This is the correct integral because in the calculator we set up g of x to be y2 and f of x to be y1. Make sure you keep track of that. Now we click enter and we get the answer. Oftentimes we want this to be in fraction form, so let's convert this to a fraction. And we get 125 over 6. That's the area of the shaded region. So we saw how to find the area of a region bounded between the graphs of two functions using the graphing calculator.